For question number 3, you have done problems like this with geranium, and you could set up a table, and you could do all sorts of things, but you're not going to do this using any old method, because we're going to use something called optimization, and optimization requires a particular setup. So the first thing you need to tell the reader is what you're trying to do. And what I'm going to do, I'm skimming over this, and I'm focusing on the fact that we're looking for the greatest area. So the first thing I'm going to write is that we're trying to maximize something. We're looking for the greatest area, so we're trying to maximize area. And what I notice is that the shape we have is a rectangle. So I'm going to say the area is length times width. Okay, now the problem with this optimization function is that ultimately I am going to be trying to graph A versus something. And I'm going to try to show the graph so the reader knows my reasoning here. But I can't graph both L and W. I need to get rid of one of them. So this is where the other information comes in. So now I am going to go back and I'm going to look at what's going on here. So we have 120 feet of fencing, and we're using a wall as one side. So I'm not going to put a fencing over here. I'll just have fence right here. So I also know, so I'm going to say we're trying to maximize this where 2L plus W is 120. So now I'm going to rewrite this objective function. My area now is, I'm going to solve for W. So the area is going to be L times 120 minus 2L. And what we know is that this, in fact, would be a quadratic. I know that if I were to multiply this out, I'd have 120L minus 2L squared. So I know that this is going to be a parabola opening down. For me to graph this, I'm going to use the x-intercepts. So I'm going to set this equal to 0 so that I can find the x-intercepts. And now I'm going to use the zero product property. So either L is 0 or 120 minus 2L is equal to 0. In other words, L is 60. So my x-intercepts are at 0 and at 60, and I know that the axis of symmetry is going to be right down the middle at L is equal to 30. So this is A versus L. And that's how my function is going to look. And if this were a normal parabola, of course I'd be drawing the rest of this. But because this is a word problem, I'm going to say and specify that the domain for this, the L values that I'm going to use, I can see run anywhere from 0 to 60. And in fact, if L is greater than 60, then width would end up being negative, and we can't have that. Okay, so now let's figure out what that vertex is. I know L is going to be 30. And if I plug 30 into this, so let me do this work, A of 30 is going to be 30 times 120 minus 60. So that's going to give 1,800. And let's just make sure that this is clear. A gardener wants to make a rectangular enclosure using the wall as one side and 120 meters of fencing for the other 3 sides. Express the area in terms of, whoops, I should call it X. I should have read that, X. So one of these is going to be X, and find the value of X that gives the greatest area. Okay, so I'm going to say the greatest area is, they don't ask for it, but I'm going to write it anyway, 1,800, and this is going to be square meters, right? The A value here when the side perpendicular to the wall is 30 meters long. And that's the solution. And this is what you need to have. You need to have an objective function. You need to write your objective function in one variable. You need to have a diagram so that I can see what your variables are or write it out. You need to have a graph so I know where these numbers come from. Don't try explaining it to me. A picture is worth 1,000 words. Show me the graph. You need to have the domain, and you need to write the answer. And that's it.